Okay, good evening. Welcome to part 2 of finding the simplest form, this time using prime factorization. Now, prime factorization has not been the kids' favorite part of our recent math practice, but now I'm hoping they'll start to see that there actually was a reason for learning how to find the prime factors of numbers. What we're going to look at in this video is how you can use prime factorization to find the greatest common factor and then use that greatest common factor to reduce a fraction to simplest form. We're also then going to look at what I sometimes call with the kids prime factorization plus, which is a way of using those prime factors that you have found to actually do some dividing out right inside the fraction and to very quickly find the simplest form using that method. So let's kick it off with prime factorization. And at the top here, you're going to see just a quick review that prime factorization was taking the numbers, like 14 and 21 from our earlier fraction, 14/21, and then using a tree, I'm going to break them down to their prime factors. So for 14, to get 14, factors of 14 are 2 and 7, because 2 times 7 is 14. And right away, this was a simple one. We will do a hard one in a moment. But this simple one, there are my prime factors. 2 and 7 are both prime numbers. I'm done. I just write out the problem. 2 times 7. Now with 21, kind of the same thing. It's 3 times 7. 3 and 7 are both prime numbers, and we're actually already there. We're done. I write out the problems, and then remember from the greatest common factors, we look for the prime factors that have something in common. In this case, there's a 7 for the 14 and a 7 for the 21. Anything they have in common, you get one of. So we pair them up. That's a group of 7. We get 1 7 for that. Had there been two other numbers alike between the two, we would have had the 7 times whatever that number was. But in this case, greatest common factor equals 7. Then if we go back to what we did earlier, after that, it's no different than what we did with the T-chart. You might remember, 14 divided by 7 is 2. 21 divided by 7 is 3, and we get our simplest form, 2/3. And I can check that because one of our quick checks that said if the numerator and denominator are 1 apart, that's one way you can tell that you have simplest form. That's not going to happen every time, but if it does happen, you can look at it and go, oh, yes, prime factorization has helped me. I have a numerator that's 1 less than the denominator. I know I'm in simplest form. The third way we're going to look at for finding the greatest common factor and therefore solving the fraction back to simplest form as far as an equivalent is concerned is prime factorization using the numerator and the denominator, or as I call it with the kids, it's prime factorization plus. This is like the really fancy way you can use a prime factorization. The kids like it. It's a little easy, it's fun. But what we do is you do your prime factorization just like we did up here. So again, with 14 and 21, I get 2 times 7 and 3 times 7. But this time, instead of just finding the greatest common factor, we rewrite the fraction, put a little equal sign, give ourselves a long fraction bar, because remember, the fraction bar is really a division bar. It's the numerator divided by the denominator. And we write those prime factor problems we had, and we write them all out completely. In this case, 2 times 7. In the bottom, we put 3 times 7. Because this is a division bar, we can divide the top numbers by the bottom numbers. In this case, I can't do 2 and 3 because I'm going to get a fraction. That doesn't work. But any they have in common will give us a factor of 1. So I can take, for example, the fact they have a 7 and a 7 alike, and I'm going to cross the 7s out. But in truth, what we're really doing is we're saying 7 divided by 7 is 1. So if you want to think of it that way, what we really did is we turned those two 7s into 1s. They canceled each other out, if you want to think of it that way, because they were alike. And it is important to think of them as 1s. They're not 0s, because there are times when the numbers will have a whole string of these in common, and you might be left with only the numerator or the denominator having a single factor left and the other one having all ones, we still want to remember that's a 1. And that will happen quite often. So if you notice, we crossed out the 2 7s. We said they're alike. 7 divided by 7 is 1. We can just simply replace them with 1s. We can cross them out. What you're left with is your multiplication problem to get the simplest form. In this case, 2 times 1 is 2. 3 times 1 is 3. So just another way of looking at finding the greatest common factor. What we're going to do next is we're going to look at one that is a little more complicated, because this one was a simple one. Let's see what happens when you get larger numbers with greater numbers of factors.